Welcome to today's video where we'll be going through problems involving polynomials and concepts dealing with polynomials. This would be a good review for any upcoming polynomial tests, and we can thank CUDA software for making this possible. Okay, example 1. I'm just going to go through these as quick and as expediently as possible. What we do here is we're going to try to find the like terms from one side and subtract them from the like terms on the other. So we look first for the negative n to the fourth. Is there an n negative or anything to the n to the fourth on the right? No, there's not. So our new results when we subtract these is negative n to the fourth, which we notice in this column there are tons of them. So they all have the same, so there's no hint there. Then we go to the next exponent down, n to the third. We do 7n to the third. We subtract it from what's over here on the right. Actually, I should be saying we're subtracting 6n to the third from 7n to the third. So we get 7n to the third minus 6n to the third. Those mean the same thing, and that's going to be plus n to the third, or n cubed. Then we look for n squared. Is there any n squared in this one? No, there's not. So we don't have to worry about it, but from that side, but we do look on the right-hand side, and we find that there is an n squared term. So the negative sign just gets applied to the n squared, so we have minus n squared. Then we have are there any n's by itself in here? No, there's not, so we don't have to worry about that. And then we look at our numbers. We have 5 minus negative 6, and that's going to become 5 plus 6, which equals 11. So that's going to match us with choice C here. All right. So you'll notice that this one was a little tricky because the polynomials were not in standard form to begin with. Next question, determine the number of roots. Well, that's really quite simple. When we have a polynomial that is in standard form, actually this is not even in standard form, it's trying to trick us. So that we look for the highest exponent, that's the trick. We look for the highest exponent when it's in this form, which is going to be 80. So the number of roots in this case is 80. Okay. Number 3, which of the following is not a factor of the given polynomial? Well, what we want to look for is if we're going to take from our binomial, we're going to take the opposite of that. That gives us the root, and we're going to do that for each one. And then we're going to plug these numbers. I don't know why I wrote the pluses in front. We're going to plug each of these numbers into our polynomial, and it's because it's wondering whatever one is not a factor, we're going to be looking for whatever result gives us, when we plug it in, gives us a result that is not 0. Because if we plug one, so it's saying one of these is not a factor. The rest of them, if you plug them in, is going to give us 0 when we do it out, use our calculator. But because we're looking for the one that's not a factor, we want to figure out which number do we plug in that gives us a non-zero result. And I can tell you, if you were to do it on your calculator correctly, you would get choice A. Okay, roots of a polynomial equation are the same as, so this is basically saying what is a synonym for roots. So that will be solutions. All right, very good. Now we're going to go on to some multiplication. So we are going to use FOIL, 5u times 2u, then 5u times 4v. We get 10u squared plus 20uv. Then we do FOIL this way on the bottom. So now we're going to have negative 6uv and negative 12v squared. We simplify the middle terms, and those look kind of similar. 10u squared plus 14uv minus 12v squared. There's nothing else to do. It's just as simple as that. Use synthetic division to find the result. So this is a straightforward case of synthetic division. We start by finding the opposite of what's in our binomial, which is going to be positive 6. Okay, which is the same as saying p minus 6 equals 0. We just add 6 to both sides, and we get p equals 6. Okay, so we put that number, the opposite of what was from here, in the top left. We'll list off our coefficients. So the coefficient here is 1. Then the coefficient here is negative 3, negative 28, and 60. All right. go ahead and follow synthetic division. We drop this 1 down, then we do 6, our top number times the bottom number. 6 times 1 is 6, so then I put that right here. Then when I have these lined up, I add, so negative 3 plus 6 is 3. Then I do 6 times 3, which is 18. Negative 28 plus 18 is negative 10. Then I do 6 times negative 10, which is negative 60. And oh, look at that, when I add these together, we get 0 for a remainder, which is very nice, which means it divided evenly. And it means that p minus 6 is a factor and 6 is a root. So that's ancillary to what we're doing. That means it's extra. It's not asked about in this question. But to write our final answer, we're going to take the exponents from here. So 1 will go in front of the p squared term. We drop from a 3 down 1 to a 2, down 1 exponent value to a 2. Then we have plus 3p minus 10. That is the result. That is our answer. Moving along. Let's see if this color works. So we're going to do the same sort of thing. We're going to take the opposite of that term from the binomial, the opposite of that number, list our coefficients, and go ahead and use synthetic division. Look at how quick this is going to be. 18, negative 10, negative 80. We're at, hopefully you know the steps by now. And 8. And so we get negative 6 here. Did I do that right? Yeah, I think so. Okay, so we have a remainder. So here's how we need to get a result, not just the coefficients, but the actual result. So this time it's a k variable. We started with k cubed, so this becomes k squared minus 10k plus 1. And then the ways that we deal with the remainder, you could just write r negative 6. Or you could write minus 6 over the binomial we had from the beginning. That's really fancy. Looks nice. Moving on. Okay, these two questions state if the given binomial is a factor of the polynomial. So there are two ways to do that. One is to use synthetic division and see if we get the value of remainder of 0. If we have a remainder of 0, then it is a factor. Or the other option is to plug in the associated root into the polynomial for n, and if we get 0, if f, or whatever, so we don't have f of x, if the polynomial equals 0, then a factor. And that's actually going to be the same for both questions. Okay, so let's see what I mean. Well, we go ahead and we take whatever our term is here, and we set it equal to 0. That's how we figure out the number we're dealing with. And we add 1 to both sides. Oh, I'm going to have to move this. So we're going to add 3n minus 1 equals 0, plus 1 plus 1. 3n equals 1, divided by 3, divided by 3, n equals 1/3. Now this problem is a very big challenge, but we can do it. So we're going to go, I think the best option, honestly, is to, it's going to require a calculator. So this is going to take a minute to do out. I'm better at multiplying fractions than plugging things into a calculator. So I'm going to do the following. Jot this down. 3 times 1/3 is 1. Add those together. That's 25. 25 times 1/3 is 25 over 3. Add these together. Well, what's this over negative 30 as a fraction out of 3? That's going to be negative 90 over 3. And put those together. That's going to give us, let's see, negative 65 over 3. And that times a third is going to be negative 65 over 9. And then we add these together. It's going to be 90 over 9. 90 minus 65 over 9 is going to be something over 9. 25 over 9. And do this again. So we get Multiplying 1 times 1/3, we're going to have 25 over 9 times 3 is 27. And then let's see what happens up here. We turn this into something over 27. Oh boy. All right, what's 11 times 27? Figure it out real quick. There's a trick, but I can't remember off the top of my head right now. So it's going to be 297. Whew, 297. Okay, something went wrong. Over 27, and I multiply 27 times 3. So we're doing multiply 1 over 3, so we get 1, 2, 3, 6, 71 on the bottom. Oh boy. $297 over 71. Well, that's going to be 4 times 71. And we read 214 on top. Okay, so this becomes 214 over 71. Subtracting that from this polynomial, we have a remainder. Okay, my math, let's see, did I copy everything over correctly? I did. Well, wait a second, what was I doing here? Yes, that's 297 over 27. Add those together. All right. Yeah, 297 on top, 27 on the bottom. Oh, I forgot to add them. So what's 297 plus 5? Let's use plus 322. So 322. Now that multiply this times 1/3, and we're gonna have 322 over 71 and 214 minus 322. This is a long process. Okay, subtract 801. 108 over 71 as a remainder. Something definitely went wrong. Oh, okay. What should the answer should be that it is a factor, so we should have gotten a remainder of 0. So this is messed up. Let's see what went wrong. That's what I get for going too fast. Do you guys see what I did wrong? Right there. Okay, real quick. The video might be glitching out a bit. So, if it's a little more complicated than it needs to be, it's good to check. Okay, so redo. Here we go. 26, negative 30, 10, 11, negative 4. Okay, 26 plus 1 is 27. 27 times 1/3 is going to give us 9. 9, negative 30 plus 9 is going to give us negative 21. Negative 21 over 1/3 is going to give us a negative 7. Negative 7 times plus 10 is going to give us positive 3. 3 times 1/3 is 1. And 11 plus 1 is 12. And 12 times 1/3 is going to give us 4. Negative 4 plus 4 is 0. So we get the remainder of 0. That means, yes, this is a factor. All right, very good. And then we repeat the same process over here. So let's see. we would get 8b plus, actually I'll change the colors. I'll just give the setup and then you can do the math. But I will tell you ahead of time that no, it does not work in this one. Or it is not a factor. So 8b plus 6 equals 0, subtract 6. 8b equals negative 6, divided by 8, divided by 8. And b equals negative 2 over 3 when I simplify it. Okay, jumping ahead. So simplify. All right, I know this is super sloppy. That's okay. So let's see. Yeah, we'll do synthetic division again. Negative 2 over 3, 40, 30, 48, 44. Just to confirm. So this is going to give us negative 2/3 times 40 is going to give us negative 80 over 3. Negative 80 over 3, this becomes 90 over 3. It's going to give us negative 10 over 3. Then we multiply again, so we're going to get positive 20 on top and 9 on the bottom. And then what happens here? I lost my train of thought. Okay, so oh boy, 432 over 9. Add those together, we get 452 over 9. Oof, we keep repeating this. Let's see, does 9 go into 452 evenly? Does not. Okay. So 452 over 9 plus 44, which is going to be the same thing as, I'm sorry, no, I forgot to multiply. Okay, I want it to be easy, but it's not. Negative 2 on top is going to give us a negative. What is, I'm going to pull up the calculator app at this point. All right, just some calculations here. Sorry for the silence. Okay, negative 904. Let's see if that divides evenly. Divided by 27. Does that work? Nope. Okay, what is 44 times 20? Oops, times 27. Okay, 1,118. So that's going to go on top. 1,118 over 27 minus, what was the double of the 452? Oh my gosh, I just forgot. Negative 904. Okay, so negative 904. We're going to add those two together, which is going to be effectively the same as putting over 27. The, let's see, 1,118 minus 904. So let's do this minus 904. 284, that's going to be over 27. Let's see, 284 divided by 27. Does that work out evenly? It does not. Okay, but regardless, we got 284 over 27. Even if I did that wrong, any of the calculations, I can tell you based on the record I have from where the problem came from that no, this will not be a factor because it did not give us a remainder of 0. All right, next question. If f of negative 1 equals 0, find all roots. All right, so this is a longer process. So when we have f of negative 1 equals 0, when we have an f of a negative 1, that's a hint that the number inside the parentheses here is actually already our root. We know it's a root. So negative 1 becomes the number inside the top left box for synthetic division. So right away they give us the number to use it for synthetic division. They give us our polynomial. We take the coefficients. And then we synthetically divide. So this is step 1. So step 1, synthetic division. All right. And because we know it's a factor, we should know ahead of time that we're going to get the remainder to be 0. So negative 1 times 1 is negative 1. Those equals 0. Negative 1 times 0 is 0. 5 plus 0 is 5. 5 times negative 1 is negative 5. And in fact, we got a remainder of 0. So now with our coefficients, we get our new polynomial, which is we're going to use the 1 for our x squared. Remember, we started with x cubed, so we're going to go drop down. Our result has an x squared. Then 0 would be 0x, but 0x just cancels, so we don't have to write anything. And then we have a positive 5 that just comes down as the number. All right, so now we know that here's our other factor. We have x plus 1 as one factor. That's why our root was negative 1, right? The opposite of this is negative 1. And then we have x squared plus 5. So to find the other root, so we know x equals negative 1 is one of our roots. To find the other roots, we set this equal to 0. So we go ahead and we'll just do this over here. X squared plus 5 equals 0. Subtract 5 from both sides. We get, oh, should have given a little more space. I'm just going to shift it over. You know what? Nope, I'll just write it up here. We get x squared equals negative 5. Square root of both sides. X equals plus minus the square root of negative 5. But we don't want to see a negative inside of a square root. So we're going to go ahead and turn that negative square root of negative 1 comes out and eventually turns into I. So we get plus minus I times the square root of 5. So x equals plus minus I times the square root of 5. So that's what this kind of problem is going to have us do. We're going to have to synthetically divide and then factor anything that's there, set it equal to 0. All right. This question has the same kind of process. It just wants us to see if we're paying attention to the fact that there's a common term amongst all three of those terms. There's a common element, and that would be x. So that'll leave us with x cubed minus 17x minus 26. All right. And then what we can do is we can still use this. I think we can still use this to find to synthetically divide. So the opposite of that is a negative 2. So we're going to synthetically divide negative 2, and we can do it just into that part. Is this true? We're going to find out. 1, negative 17, negative 26. Drop down. 1, negative 2. Add those negative 19. Multiplied negative 2 times negative 19 is going to give us positive 38. Add those together. We're going to get 12 as a remainder. Okay. So, nope, we cannot do that. We cannot factor out the common x first. I thought I was being sly, but we cannot. All right, so we're just going to take the opposite of this to get the negative 2, and then synthetically divide and use our coefficients. 1, we have to use a placeholder. 0 is a placeholder. Then we have for the x cubed, there's 0x cubed. Okay. Then we have a negative 17, negative 26, and we don't have to do. I don't believe we have to do a placeholder here for the. No, we do. We got to put a placeholder for where the number would have been. Right. This is the same thing as plus 0. Okay. So drop it down. 1 times negative 2 is negative 2. Add those together. We get negative 2. Negative 2 times negative 2 is positive 4. Add these together. Negative 11. Sorry, that's not right. Negative 13. Negative 2 times negative 13 is positive 13. And then we have negative 2 times negative 13 is positive 26. Those give us 0. And it turns out we did not have to do that part. So remainder is 0. And then we're going to rewrite this polynomial as x cubed minus 2x squared, even though we didn't have an x cubed to begin with. We just use these as the coefficient for the next part. Minus 2x squared minus 13x plus 0. All right, so now we can go ahead and this is our new polynomial, and we're going to factor out that common x. So what happens is we have x times x squared minus 2x minus 13. All right, this time, if we tried to factor this, it wouldn't work. We can't find two numbers that, actually maybe, no, we cannot find two numbers that multiply to give us negative 13 and add to give us 2. So we're going to have to use the quadratic formula for this part, okay? So we're going to have x equals negative b, so a negative 2 plus or minus the square root of negative 2 squared minus, I'm just assuming you know what the quadratic formula is. Oh, I don't know what that is. Okay, for a was 1, c was negative 13 over 2 times a, which is 1, so it's going to give us x equals 2 plus minus the square root of 4 plus, see, 4 times 13, oops, negative 4 times negative 13 makes it positive, that's why there's a plus sign, and 4 times 13, off the top of my head, I don't know. Right. So we're going to get 12, 52, so 4 plus 52 over 2. That's going to equal 2 plus minus square root of 59 over 2. Okay, so that's totally fine. So that's 2 of our roots right there. It doesn't matter that it's in a square root. Then we have this is really being set equal to 0. So our roots in the end, we get from our, using the quadratic formula here, we get x equals 2 plus minus square root of 59 over 2. We could simplify that just a little more, but to 1 plus minus square root of 59 over 2. But we don't need to do that. It's a little more work, and what we have is perfectly fine. But also this okay, so here's the big part. The number out, the letter out, the variable out front, x. Well, that's also technically being set equal to 0. And the quadratic formula is actually what happens if we set this equal to 0 and solve. So we have our root x equals 0. And you might think, oh, well, we're good. But nope, we can't forget of what the term we got from the beginning, the root we got from here was negative 2. So x equals negative 2. And let's just see, do I have the review pulled up? Okay, let me confirm. All right, so we see that the answer was in fact wrong. I'm sorry. So for number 9, what we did earlier, we were correct. There was no remainder. There was a remainder, so it's not a factor. All right. Number 11. Yep, we did it right. We got all the roots. Okay. This doesn't look like the roots. It just tells us the factors, but from the factors we get the roots. We are making great strides here. We're almost We're almost halfway through this. So back to work. All right, determine the number of roots and x-intercepts. Let's pick a different color. Let's go pink. Okay, so to determine the number of roots when it's in factored form, we look for the number, we look for adding up all the exponents, and we remember if there's an exponent up here, we multiply that times the exponent inside the parentheses. But for this one, we don't have to worry about that for the number 12. So we just get the 2 from this first term, from this first binomial, plus the 2 here. So that's going to give us 4, plus 2 more is going to be 6, plus 2 more is 8. So there are 8 roots. Then we want to figure out, actually, let's leave that 2, 2, 2, and 2. Wow, those are bad 2s. Okay, then we've got to figure out how many x-intercepts there are. The way to do this is as follows. We can set each term equal to 0. Okay, so option 1, set each term equal to 0. And option 2 is a little trick. What a little trick would be is that if we have x squared minus some number, so we'll just do c for some number, then we have two real roots. But if we have x squared plus some number, two imaginary roots. Okay? So if that's only for x squared. Only works for x squared. All right, so we're going to use our trick. So from here, we're going to get, let's do it in red, option 2. So from here, we're going to get two roots, two intercepts, 0 intercepts, 2 intercepts, 2 intercepts, and 0 intercepts. And the reason is because if you set this equal to 0, you're going to end up with something like 2x squared plus 1 equals 0. Subtract 1 from both sides. 2x squared equals -1. So automatically, no matter what happens, you can't really see that, but you're going to end up with x squared equals a negative number. And if you take the square root of both sides, well, you're going to end up with x equals plus minus I squared to 1/2. Okay, so we know it's not going to work out. All right, let me erase real quick. Sorry about all the glitching. Oh boy. It is not working very well. Okay, so now we've got 4 x intercepts. All right, now we're going to use our same process for the other example. So let's tally up our total number of roots. So here's 15, 6, 5, and 3. So in total we have 21 plus 5 is 26, plus 3 is 29 roots. And then we're going to, this time, here's the other trick, is that when we have anything that's not an x squared, each term is going to give us 1 root. Okay, so this time, sure, we'll use this color. So this time we get one x-intercept from here, 1 x-intercept from here, 1 x-intercept from here, and 1 x-intercept from here. So there's only 4 x-intercepts, and I'll just write that little reason here. When exponent is really when it's odd, or of the binomial inside the parentheses, when exponent is odd, so I'll put a little 1 here, 1 x-intercept. Okay, very good. Moving to the next one, factor to find all roots. All right, so let's definitely focus here. So we're going to go ahead and recognize the key piece of information here is that there are 4 terms. So when we have 4 terms, we are going to need to factor by grouping. Okay, so then we put parentheses on the first 2 terms, parentheses on the second 2. Just write that off to the side, grouping. Now we're going to take out the GCF from our first binomial, so that's going to be an x to the 4th, and that's going to leave us behind with an x squared. Because remember, when we divide something out with exponents, we subtract the exponents, and taking out the x to the 4th gives us a -1 here. And then this next binomial, we're going to want to make sure that we end up with x squared minus 1 in these parentheses, so we got to take out a -16 this time, because that makes our x positive, x squared positive, and then our 16 here, when we divide out the -16, this gives us -1. That all equals 0. All right. Then we're going to go ahead and say x to the fourth minus 16 is in one parenthesis and x squared minus 1 is in the other. Now, here's the trick. Here's the truth, is that this is actually the difference of two perfect squares, and it's going to keep breaking down. It would technically break down into x squared plus 4 and x squared minus 4. All right. And then this one breaks down into x plus 1, x minus 1. Okay. So this is a very challenging question. Here we go. So now we're going to set each thing equal to 0 to get our roots. Well, actually, these ones we can use our trick. We just know we take the opposite. So x is going to equal -1, x is going to equal 1. All right, and then let's take x squared plus 4 from here. Just put it over here. Set it equals 0 and solve. Okay, so x squared equals -4 square root of both. X is going to equal plus minus the square root of -4, but that's really the same as x equals plus minus the square root of 2i, because the square root of 4 is 2, and then taking out that square root of the negative, that gives us an I. So 2i. And if we take this one, x squared minus 4, set that equal to 0, we're going to find out that we get, add 4 to both sides, take the square root of both sides, x equals plus minus 2. So these are the roots. All right, so there are a lot of roots. In fact, there's 1, 2, 3, 4, 5, 6, which we knew would be the case from the beginning. Okay, next example. Let's go back to a fun color. How about this dark purple? Okay, so this one, the first thing we have to identify is taking out a GCF. All right, so we're going to take out the common x squared from everything. That's going to leave us with x to the 4 minus 3x squared minus 10 equals 0. This one is going to be solved by using substitution. Okay. The key here is to recognize that we have x to the 4 out front, and that we have 1, 2, 3 terms total. So that's how we can identify it, or that we're going to use substitution. Another way to identify is that, well, we have x squared in the middle. Normally we just have an x there. And so when we have x squared here and then x to the 4th, well, that's really like an x to the 4th is really x squared squared. Okay. And so having the x squared in the middle can also be a key or a hint of what we're going to do. And then that x squared from earlier comes out front. Okay, so that all equal to 0. Now we're going to use substitutions. We're going to say let u equal x squared. Well, we can ignore this one because you'll see at the end why. But we're going to replace this and this with u. So we're going to have u squared minus 3u plus 10 equals 0. And now this looks like a quadratic we're used to dealing with, so we can go ahead and factor this out using the x method. What two numbers multiply to give us 10, add to give us -3, and that's going to be -5, and sorry, yeah, negative. I'm having a blank at the moment. It's 5 and 2 for sure. I made a mistake. It should be, when I rewrote it, when the screen was glitching out, it should be a -10. There we go. So it should be -5 and +2. So we're going to have u minus 5 and u plus 2. And now we're going to go ahead and substitute this back in. And we're going to get x squared minus 5 x plus 2, x squared plus 2, and that equals 0. And now this one comes out at the very end, x squared. And then we set each term equal to 0, or each factor. So x squared equals 0. Well, that's just going to take the square root of both sides, but we really just get x equals 0. X squared minus 5 equals 0. Okay, add 5 to both sides. X squared equals 5. Take the square root. So x equals plus minus, can't forget that, square root of 5. And then x squared plus 2 equals 0. Subtract 2 from both sides. You're going to get x squared equals negative 2. Take the square root, and x is going to equal plus minus square root of negative 2. But we know that we don't like writing it like that, so this negative is going to ultimately just come here as the letter I, so plus minus I root 2. Okay, so this bottom two, the bottom one over here, the bottom one in the middle, and this one. These are all the roots for number 15. Let's see what else we got. Describe the end behavior. Okay, if it's an x to the 4, we know it could have a W shape. So that tells us, it's not the best W, but it tells us the arrows are going up. So we have 2 up arrows. Negative out front flips that around, 2 down arrows. It would give us an M shape, possibly. Sketch the general shape of each function. All right, so all you have to do for this one is come up with a set of axes. All right, ideally you're going to label those. And negative x cubed. Well, positive x cubed is this sort of S shape, so negative x cubed will be the other direction. It goes through the origin. Oh, it wasn't perfect there. Let me retry. Through the origin. That's what it's like. The highest exponent drives the bus. It tells us what the shape will be. And then x to the 4, we actually went over that a second ago, but we're going to go ahead and do our axes. And we can go ahead and make a W shape, and it's going to look like that. All right, there you go. So how we would do this is make number 21, make a chart / table, and then graph. Real quick, I'm just going to give you the answer to this one. Is going to be, let's see, 5 with a multiplicity of 2. So that means we're going to have x minus 5 quantity squared. And then the term x out front. So there's a polynomial function that will have least degree and has these given zeros. This is a really good challenging one. Probably not something you'd see unless you're in an honors class. And last, x cubed. We're going to subtract 1 from both sides. I know I'm going fast. Take the cube root of both sides. So x will equal what number multiplies. What am I doing? I'm doing something wrong here. Oh, yes, this is a special case. This would be a case of a cubic, yeah, a sum of 2 perfect cubes. So that's going to give me, I think, x plus 1. I can't remember the exact formula now. And then we're going to get x squared. It's a plus sign. I think it's plus x minus 1. Okay, and then we would factor that. And let's just look at what the answer is, because I forget. Oh, here we go. Let's see. Is going to be letter B. All right, so there we have it. We just set it equal to 0. Solve by setting each term equal to 0. Or each factor. Okay, there we go. There's a nice long video for us on different techniques and ways of answering questions about polynomials. Thank you for watching this edition of Zombek Easy Math. Remember, we're doing this so we don't turn into a math zombie in the classroom.